In number 43, we have another word problem. This is a dock of the bay type problem where we're looking at high and low tides. Let's first sketch a graph. It says at Ocean Tide Dock, the first low tide of the day occurs at midnight, when the depth of water is 2 meters. The first high tide occurs at 6:30 a.m. with a depth of 8 meters. Since high tide is 6.5 hours after low tide, and this is half a cycle, when we put in a full cycle, it should be 6.5 hours later, which of course would be 1 o'clock or 1300 hours. Now, let's draw in our graph. Notice that our maximum is 8. Our minimum is 2. Our midline, therefore, is an average of those two values, or 5. Our period is the length of the entire cycle, which is 13 hours. From these, we're going to find A, B, C, and D so that we can write our equation. A is the difference between the midline and the maximum, which is 3. B is calculated from the period. 2 pi over B has to equal 13 over 1. Cross multiplying gives us 13b equals 2 pi. Divide both sides by 13. We get b equals 2 pi over 13. Our c value is 0 because 12 o'clock is our starting value. And our D value is our midline of 5. Now, let's write the equation. It says in part A, sketch and label the graph. In part B, determine the trigonometric model. In this case, we have a cosine function, but it's negative. So we're going to write y equals negative 3 cosine 2 pi over 13. Now I've been writing theta, but of course this is really in terms of t. So 2 pi 13 theta plus 5. The last part of the question says, suppose a tanker requiring at least 3 meters of water depth is planning to dock after midnight. Determine the earliest possible time that the tanker can dock. Now this is a y value of 3. So go to y2 in your calculator. Of course you're going to put your first equation in y1 and put in y2 equals 3. And then we'll find the point of intersection. The first point of intersection to occur. Remember, do second trace, number 5, intersect, Get as close to that point of intersection as you can and do enter, enter, enter. It will jump from the first curve to the second curve, then to the point of intersection. In this case, the x value should equal 1.740. Now, in terms of time, 0.74 of an hour is 44 minutes. So this should give us a real time of 1:44 a.m.